Alright, good morning guys. Today we're going to look at SPI 4.2. That's graphs of trig functions. That's taking your sine, cosine, tangent, secant, cosecant, cotangent, all that trig stuff, and actually graphing them. Pretty straightforward. We're going to let the calculator do all the real work. We just have to do a little bit of the analysis on it. So let's look at the first example here. Which graph best represents one cycle of the y equals sine of x over 2? So let's just start by keying this in. They give me a y equals. I'm going to punch in the calculator, see what the picture looks like. So if we grab the calculator, and I just go to y equals, and I type sine of x over 2, x divided by 2, close it, and I graph it, I'm going to get this picture. If you didn't get this picture, it means your calculator is not set on radians. If you just got like a straight line or something, or a little slash line, I don't know what you would get. Remember, mode, you have to be on radians to do any trig stuff. So we get this graph. All right, let's actually look at it. There's the graph. And then they want to know this graph matches which of these pictures. Well, my graph doesn't match exactly. I've got a lot of stuff going on here on the left side that they don't have anything on the left side of any of their graphs. So we use this, we need to read carefully, and this is one cycle. Well, one cycle or one full wave. That's until the pattern starts to repeat. So see how it goes up, then down, then up, then down. So the pattern is up, down, up, down. Well, just based on the one cycle, I know B is incorrect because it goes up but it doesn't come down, so it doesn't have one full pattern. So B is out. Now we just start digging around. This is one cycle, up, down, up, down. Well, this one didn't go up, down. See how this one goes down and then comes back up? It's kind of a backwards pattern. Ours started at the origin like A and C do. This one right here starts at 1. So just based on the shape, we know that choice D is out. So we're looking at just really the right half of the graph. It's got to be either A or C. Well, what's the difference in A and C? A, we end at 4 pi. C, we end at 2 pi. Well, I don't know what that means, so I'm going to go to the calculator and just figure out what 4 pi and 2 pi are. So if I grab my calculator and I just type 4 pi into the calculator, I get 12.57. If I key 2 pi into the calculator, 2 pi, I get 6.28. So this one ends at 12.57, this one ends at 6.28. Well, where's my graph end? Well, my graph's going to end somewhere out here. Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my graph looks like it ends out here closer to 12 than it does to 6. So based on where this says the endpoint should be, 12.57, A is the most reasonable graph of this equation. So choice A. Now let's work the other way, where instead of taking one equation and finding the appropriate graph, let's take the graph and find the appropriate equation. When I have this, I like to go and adjust my window because I want to be as easy as possible. I want to match picture to picture. So I want to make the window of my graph, which is normally negative 10 to positive 10, negative 10 to positive 10. I want to make it match theirs. Let me clear out that. So I'm going to hit my window button right here, and I get to adjust it. X minimum, X maximum. X minimum means the leftmost X. So the number I see on the left is negative pi. So I'm just going to put negative pi. Negative pi. X maximum, that's the rightmost number on the x-axis. So I'm going to put positive pi. Positive pi. X scale. That's how wide are your blocks going to be. So if I look at it, well, I don't really know how wide the blocks are going to be. I got a pi over 2 here. That's 2 blocks. So I just need half of that, correct? So I'm going to put pi over 2. Oops, pi over 2. And there's 2 of those, right? 1, 2 of those to get to pi over 2. So let's just put that twice. X's, or Y's. Y minimum, that's the smallest Y. That's negative 5. Y maximum, positive 5. And then the Y scale. How wide is one block on the y-axis? Just 1. So it was labeled. I didn't have to do it divided by 2, divided by 3. All right, so leftmost X, rightmost X, how wide one block is. That's your X numbers. Bottom Y, top Y, how wide one block is on the Y's. Now I can see my graph is going to look like their graph. Okay? Negative pi and all that stuff. So we get the same picture. Now we just key in our choices. Sorry, if we look back at the graph, we've made this graph. So really we've boxed it out here, negative pi to positive pi, negative 5 to positive 5. So we're really just looking at this window. So I want whichever of these four choices is going to give me this exact picture. So that's the thing. The reason we want to mess with the window, because then we just match the pictures identically, and we don't have to do like we did on the last one, where we had to do 2 pi and 4 pi and figure out what those were as numbers. We're just going to match picture to picture exactly. So I'm just going to key in my choices one at a time. So start with the first one, 2 tangent of x. And if I graph it, I get this picture right here. So I get a half, a whole, and a half. Well, that's not what I'm looking for. I'm looking for half, 3 wholes, and a half. All right, so there's choice A. Doesn't look right, but we'll hang on to it. Choice B, tangent of 2x. Graph it, half, whole, 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 and another half. That one looks right, but we want to make sure that they're not going to do something funky. So always be suspicious when you get the right answer pretty early on. We'll go through and check all the other ones just to make sure. Choice C is 1/2. So I'll put parentheses around that because it's a fraction. 1/2 tangent of x. Graph it, and I get a half, a whole, and another half. Okay, so it looks a lot like choice A, so that one's no good. So B still looks pretty good. Now let's look at choice D. Tangent of 1/2. We'll put it in parentheses. X, close the parentheses. So tangent of 1/2 x, graph it, and I just get 1 whole, it looks like on this one. All right, so there's choice D. Well, we need to get a half, and 3 wholes. Well, that's going to be choice B. Pretty straightforward. There it is. Okay. So the idea is, if you've got equations to match to one graph, adjust your window so that your picture is going to look exactly like their picture, and you just match them straight up by keying them into y equals. Or if it's like the last example where we have a bunch of pictures and one equation, key in that one equation and just play around with the numbers each of those pictures gives you until you can get the correct answer. All right, that's trig graphs, and I'll see you in class tomorrow, guys.